So we are continuing our discussion with chapter number 8, which is Introduction to Trigonometry. And in this video, we are going to discuss the last section of this chapter, section 8.5. It's called Trigonometric Identities. Now, first, before starting with this video, let's try to understand what is the meaning of identity. The word identity has a special meaning in mathematics. Okay, and that has been noted down here. So the word identity means, let me try to remove this. Yes, so it means an equation that is true for all values of its variables. Now assume an equation which has one variable, or assume an equation which has two variables. So no matter what value you put, for all values, for each and every value that the variable can take, that equation is always true. Such equations, such special equations are called as identities. Okay, and in this section we are going to see trigonometric identities, which means identities that involve trigonometric ratios: sine theta, cos theta, tan theta, cot theta, sec theta, cosec theta. These 6 trigonometric ratios. Involving these trigonometric functions, we are going to discuss certain identities. So let's continue our discussion. Okay, so first let me draw a right angle triangle here. Okay, and this is my 90-degree angle. Okay, let me write it here. This is my 90-degree angle, and these are the three vertices of the triangle A, B, C. Now, using Pythagoras theorem for our right angle triangle, I can say that AC square, which is my hypotenuse, is equal to AB square plus BC square. Okay, so this is my regular Pythagoras theorem for any right angle triangle. Now what I'm going to do is I'm going to divide both the sides of equation by AC square. Okay, this variable AC square I'm going to divide on both the sides of equation. So let's perform the division and let's see what do we get. So therefore, we get AC square divided by AC square, that is equal to AB square divided by AC square plus BC square divided by AC square. Okay, so we have divided both the sides of the equation by AC square. Now very clearly, this AC square divided by AC square is 1. So I'm going to write it down 1 as equal to this. I'm going to write AB divided by AC the whole square, okay, plus BC divided by AC the whole square. Okay, just rearranging the square term. Now let's focus on this angle A. Okay, angle A is our angle of focus. Now with respect to angle A, if you consider sine A, let me use, okay, so what is sine A with respect to angle A? It is opposite BC upon hypotenuse AC. And what is cos A? Cos A is equal to adjacent AB upon the hypotenuse AC. Now if you look at these values, these fractions and these fractions, we can substitute. Okay, AB by AC, let me use a highlighter here. Okay, so AB by AC, this is AB by AC, and BC by AC, this is my BC by AC. So let's do the substitution, and therefore I get, therefore 1 is equal to AB by AC is cos A, so it's going to be cos A the whole square, plus BC by AC is sin A, so sin A the whole square. Okay, thus we get this identity. Okay, 1 is equal to cos A whole square plus sin A the whole square. This is true for all the values of A. Okay, it doesn't matter what is the value of A. A is any angle. A is any angle of this right angle triangle. So it can have 1 degree, 2 degree, 10 degrees, 45 degrees, 60 degree. No matter what is the value of A, cos A square plus sin A square is always going to be equal to 1. So that becomes our identity number 1. Trigonometric identity number 1. So I'm going to write here, okay, trigonometric, short form, trigonometric identity. This is our trigonometric identity number 1. And what is that? So typically we write it as, okay, sine square A plus cos square A is equal to 1. and let me use a highlighter to highlight it. This is my trigonometric identity number 1. Sin square a plus cos square a is equal to 1. And there is nothing special about this angle A. This identity is true for all angles. So even if you take angle C, okay, sin square C plus cos square C will also be equal to 1. Or rather, sin square theta plus cos square theta is equal to 1 for all the angles for any values of these angles. Okay. Now, this becomes our identity number 1. We have two more such identities. Let's see how we can derive them. In order to derive them, I am going to take this triangle along with the Pythagoras theorem. Okay, so copy. Let's come down. Okay, and paste here. Okay, yes. So once again, we have our right angle triangle ABC, and from Pythagoras theorem, we have this hypotenuse square is equal to side square plus side square. Now, in the above equation, we divided both the sides of equation by AC square. Now, in this discussion, we are going to divide both the sides of equation by AB square. So, let me write it down. So, divide both the sides of equation by AB square. Okay. So, let's write it down. So, we'll get AC square upon AB square is equal to, here we get AB square divided by AB square plus we get BC square divided by AB square. Okay. Now once again, this AB square by AB square is 1. So let's just write it down. That is very obviously 1. And these terms I'm going to write BC by AB the whole square. Okay. And this I'm going to write AC by AB the whole square. Okay. So now this is my equation. Now once again, let's focus on our angle A, and let's try to figure out, okay, what this fraction stand for. Okay, now AC by AB is this hypotenuse and this adjacent. So we know that sec A, okay, I'm going to write here, sec A is actually equal to AC by AB. Okay, so actually cos A, so sine and cos are the foundation basic trigonometric identities. From these, other identities are derived. So you should just remember these two and then derive the other ones. So cos A is adjacent divided by hypotenuse, and sec A is just reciprocal of cos A. So it will be hypotenuse divided by adjacent. And similarly, we have tan of A as equal to opposite BC divided by adjacent, which is equal to AB. Okay, and once again, let me use a highlighter of different color. Yes, and once again, we have AC by AB. Okay, AC by AB, and we have BC by AB, and this is our BC by AB. Okay, so thus we can substitute. So let's substitute, and therefore we get AC by AB is sec A. So sec A the whole square is equal to 1 plus this is tan A the whole square. And thus I have got my second identity, which involves two trigonometric ratios, tan and sec. So let me make a note of this. This is my trigonometric. This is my trigonometric identity number 2, and typically it's written as 1 plus tan square A. 1 plus tan square A is equal to sec square A. Okay, and let's use a highlighter to highlight this trigonometric identity number 2. Okay, now again in a very similar fashion, we are going to go to trigonometric identity number 3, and so let's scroll up. Okay, so in this Pythagoras equation, we divided both the sides by AC square. Here in this equation, we divided both the sides by AB square. So now in the third part, we are going to divide both the sides of equation by BC square. Okay, so let's do it. Let's zoom in. Okay, now I already have this paste. Yes, so this is my Pythagoras theorem. Yes, so again we take this right angle triangle ABC, and this is by Pythagoras theorem. Now here we divide, so divide both the sides of equation by BC square. Okay, and therefore we get AC square upon BC square is equal to AB square upon BC square plus this is going to be BC square divided by BC square, and therefore this is going to be AC. Okay, first let's do the obvious thing. Okay, BC square divided by BC square is equal to 1, so I'm just going to write here plus 1, and then I'm going to just rearrange AB by BC the whole square, and this is AC by BC the whole square. Okay, once again let's focus on angle A. So with respect to angle A, AB by BC, okay, adjacent divided by opposite is cot A. So I'm going to write here directly this time. So this is equal to cot A the whole square, and this is my plus 1, and the left hand side of the equation is AC by BC. So AC hypotenuse divided by BC. So sine A is opposite upon hypotenuse. So 1 upon sine A, which is equal to cosec A. Okay. So I'm going to write here cosec A the whole square is equal to cot A square plus 1. And thus we have got our third identity, identity number 3. Let's make a note of that. We are short of space, no problem. So we have this trigonometric identity, okay, number 3, and that is typically written as 1 plus cot square A, okay, is equal to cosec square A. Yes, and let's again use a highlighter to highlight this. This becomes our identity number 3. So thus in this entire page, okay, you can say this is our identity number 1, which involves sine and cos. Identity number 2, which involves tan and sec, and very small identity number 3, which involves cot and cosec. So thus we have discussed 3 different identities, trigonometric identities, in this entire video.